Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 365. Count visited nodes in a directed graph. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one is a sort of a textbook problem, but to be honest, I was very bad about memorizing it. I think for me, I'll go over my code, but I will also go over how I wish I wrote the code because I took a long time just also. And this is a little bit of a blame game, but I blame on the fact that like the inputs are kind of really hard to draw. I got a wrong answer very quickly, but then it took me like a long time to draw it out on paper, and I drew it incorrectly a couple of times. That's why I couldn't debug it for a long time, which is as they say, very sad. But for this one, yeah, the idea obviously is that if you are not careful, you're going to do n squared, and n is 10 to the fifth, so that's going to be too slow, right? And this is a functional graph, meaning that every node has an edge out, and so there's some properties of that. I don't know that much about those properties, but that also means that there's going to be at least one cycle, and yeah, there's going to be at least one cycle because there's n graphs and also n nodes and n edges, right? So yeah, there's going to be at least one cycle, so you have to think about how to handle the cycle. And in this one, I don't think there's anything arithmetically complex as long as you know not to, not to do it naively. Then, like, all right, well, just if you want to speak it in English, that algorithm is pretty straightforward. You do some magical thing, you find the cycles, and when you see a cycle, you just add one and then kind of like add up the tails, right? So that's the idea, and I implemented it that way, but I definitely was not careful about it, to be frank. We'll go over the code now, and we'll go over the code as I've written it during the contest, so it's not super clean, but I'll talk about how I would want to have implemented if I had a better understanding of the problem. Because there's a lot of like hacks. I mean, it works, but I don't know. So yeah, so first of all, yeah, I mean, I basically have a sort of a thing, right? So the way that I think about this, writing this, is that the two states for a given node, right? There's one for visiting it during this current depth first search, and then so that you draw like the edge, and then there's another one for visiting it before that, right? Yeah. So basically the idea, and I'm going to actually do some drawing real quick. It's not on the thing. No, hang on. Right. Basically you have idea of like, and I'm just going to keep it simple, just keep it to one cycle, but obviously there could be many more. I don't know if this is way terrible drawing, but right. And then you have extra edges like pointing out, and then the tricky thing about this one is that, and maybe you could do like a topological sort or something like this. Maybe that would have actually fixed some of the stuff, but maybe not even all of it, to be honest. So you still have to be careful. But the idea here is just keeping track of how to find a cycle, right? And keeping in mind that you can start a DFS at any node, right? So at least that's the way that I did it, is that I just kind of be able to start every node. So here, let's say, you visited this, you visited this, you visited this, and then now you see the same node, and you're like, okay, well, and this node, we did it in this cycle, so we know that, or this process, as they call it, so then we know that this is a cycle, so then we do the math, we propagate that there's 4 nodes, up here, up here, up here, and up here, right? And then now, when we kind of look at it next, let's say this one, well, we know that we go to a loop, so we can just lazily do a 5, do a lazy 6, right? But of course, you can also do it in some like funky order, right? So for example, let's say we do this one first, and this is a 5, and then now we do here. How do we tell that, we know that we visited this node, but we have to be careful that to not count it as the way that this was visited in the same process, because we visited this node before, but it is in a different process. So we just have to kind of keep track of all these things. And as long as we do, it should be fine. It's just a lot of different test cases or input cases. So first of all here, like as we said, we kind of go for each node, we calculate it. And this one, I think, as I said, I did it with a depth first stack, but I should have just used a more explicit stack, because you notice that I have a lot of like weird states that I could have just not done it as part of the recursion, because then I could have put more while loops in different ways. Because the reason with that is that now in that case we would have more better loop invariants, so that it's easier to kind of figure out here, because as you can see, I have like, I don't know, I have 5 distinct cases, and even then it's like a really messy way to kind of think about it. I mean, I'll talk about it, but I don't think this is the clean way to write it. I think the clean way would be to use an explicit stack and then just have a while loop, and then within that loop you would have like loop invariants, so that every after every loop you have states, and you kind of figure it out that way. But yeah, but basically the idea is we keep track of 2 things the way that I did it. One is the answer, and one is the visited array, right? So visited is basically the time that we visited for this current node, and if we are visiting it for the first time, which is when it's in infinity, we update the time that we visited, and keeping in mind these are functional, so it should be fine. If we haven't visited the next node, then we want to visit the next node, right? And this is the part that, like I said, the state machine's a little bit awkward. That's why it's a little confusing. So we'll jump ahead a little bit to explain it. But let's say we have visited this node. So if we have visited this node before, then what happens? Well, if the answer is not none, that means that we already calculate the answer. So then we can just, this is just 1 plus that, right? But if the answer is, if we have not calculated the answer, that means that this is one of the cycles that we calculated. As I said, this is the way I wrote the code is very messy. I don't recommend it, but I'm explaining it, so But yeah, but this means that we visited, or the node that we're about to go, this is the cycle. This is part of the cycle. So we have to calculate the answer, and to calculate the answer, this is the time that we have reached this node, and the last time we reached that node, so that's the length of the loop, and then plus 1 for the number of edges, right? And that will give us the length of the node. And what I do is I do a hacky thing where I'm like, okay, well, update this. So basically this is, if you kind of think about that as a stack, you want to go backwards up the loop until you see the point in which it is a cycle. And that's basically what this does. It sets this until thing. And then now, so basically, to get the answer, it goes, okay, well, if this node is equal to until node, then we set the cycle is equal to this, and we found this. So then now, I guess I could have also set until is equal to false now that I kind of did this loop. But yeah, otherwise, so basically this is now at the root of the cycle. So then we set the cycle for the last time, and then we set this thing equal to found, so that in the future it could be added plus 1, because everything that points to it, it's an entry to the cycle. And that's pretty much it. Otherwise, this is for everything that's inside the loop, right? So okay, let me add comments. So still inside the loop, last element on the loop, last or first, depending how you want to say it. And then here is not inside the loop anymore, right? So maybe I could have actually done something like this, to be honest, and then just set like until it's 0 to none again, right? And then now I could just do this. So then now not inside the loop anymore, right? I think this works, hopefully. I don't know. I mean, the other one works, so we'll see. Yeah, okay, yeah. And then this is we already calculated the answer previously, and then now we've seen this loop, but we don't have the answer. So this is part of the cycle, right? So that's basically it. The idea is kind of simple per se, but I mean, it took me a long time to implement this, and I still got a wrong answer because I had a case where the ordering was just weird, and I didn't have this not inside the loop anymore case. So yeah, this is linear time, linear space, because for each node we only visited once, or I guess twice on the way back, if you want to call it that. But like a linear couple of times, and of course we have linear space here. So yeah, let's show the function again, and the rest of it is just a for loop. So yeah. That's all I have for this one. Let me know what you think. You can watch me solve it live during the contest now. Let's give it some minute. It's probably not right, but okay. Silly mistake on Q2. All right, let's focus. Directed graph, count visited nodes. I didn't even read the prompt. Okay. Directed graph, you start with the node X and keep visiting until you reach a node that you already visited before in the same process. There's a number of different nodes if you visit one source from node I. Okay. Oh, it's a functional graph. Okay, that makes sense. Can you cache? No, because I have this cycle thing. People know how to do it apparently, but let's see. It's a functional graph, so so we have to find all the cycles and then just get all the entrance. It could be many cycles. They don't have to be okay. How do we find if there's a cycle without weirdness? Okay. Okay, I mean, I think it's just depth of search, but in a very careful way. So as soon as you visited someone you visited, there's a cycle. Okay, right. So okay, and then we have an answer thing. It's not quite like that. I should know how to do this. This one is the textbook, but I'm a little bit sloppy in thinking about it. Okay, I mean, I have to get it right. So we start from node. Let's go. Good luck. Okay, Jesus. Yeah. And then if we visited this one, but not on this branch, right? Otherwise, so if we haven't visited, we visited. It's fine. Otherwise, Okay, so we have an answer for this node and we've already done this. Yeah, if answer node is not none, then answer of, oh whoops, if the answer of the next node is not none, so we have visited, then okay, the answer of node is equal to this plus 1. Otherwise we visited this on this particular thing. So then now this is the loop. What is the loop? What is the current t, right? Otherwise, okay, so the current t is everything in between. So answer sub node is equal to visited of okay, so this is the last element of the node, so then you want the visited address of node, that's the previous one, and then visited of node minus this, right? And then now you want everything until, right? So maybe some weird this is very awkward, but this is why sometimes we use an explicit stack. But so basically we want to pop until we get it. Okay, so then now if we calculate this node, we want to get the answer, right? So if node is equal to until if this is not equal to until, then answer of node is equal to answer of edges of node, because this was part of the cycle. Else if this is the until, then we plus 1, because we've already done it, and then okay, let's write this a little bit more coherently. Okay, is this case? Okay. Else if found, then yeah, kind of like this. I don't know. Where line 10, do I not always call it this? Yeah, okay, fine. I actually don't know how decoration stuff necessarily works. Line 13. Oh, whoops. No, that's not it. That's just me being dumb. And I do the same thing. I don't update that here, so I guess that's why. Yeah, whatever. Infinity for a lot of stuff. That's not good. Did I at least get the first one right? I did not get the first one right. Oh no, that is the first input, I suppose. Oh, I don't have a base. No, this is the base case, I think. If it's not none to do, if it is none to do this, and then this. This is gonna be yucky. 0, 1, 2. Okay. So it's printed out, apparently it doesn't. Okay. So there's some weirdness here. 0, 0, 0, 0. That's really not right. But do we not go here? Oh, edges. What am I doing? No, of course this is not right. If visited of this. Okay, maybe this is better. Okay, 2, 2, 2, 3. Okay, 4, 4, 4, 4. So I mean, off by 1, but that's fine. In theory, okay. Are we right? I don't even know. I feel like I have a lot of silly mistakes lately, so let's try something real quick. Oh, I guess that's not right test because I wasn't sure. I didn't know that cannot be though. I don't know why not. Okay, so let's say you have. Okay, so probably could submit actually, but oh well. Something like that. Let's see. Okay, that's good. And then maybe something like. This would be 0, but this is 5, 6, 7, 8, 9, 10. There should be a string. Okay, and it goes that way. So okay, let's give it submit. Maybe I still miss an edge case. Okay. Huh. Okay, so let's figure it out. So 3 is 0 goes to this is so hard to draw. 0 to 3. Well, I'm just dumb. 1 to 6. 6 to 1. Okay. Oh no, that's 2 to 1. Whoops. I can't even read this right. 2 to 1. 3 to 0. Okay, so those things are good. Did I mess up the T's? Anyway, 4 is to 5. 6 is to 7. 7 is to 4. 2, and then 8 is to 3. I think I just forgot the actual regular case of no until. That is. Wait, is that true? No, that's not true. That can't be. What's 5 pointing to? 5 has to point to something, right? So 0, 1, 2, 3, 4, 5. 5 point to 7. Okay. So I missed something. Yeah, okay, so I just missed one. So 0 is 2 is right. 6 is 7. Oh no, that's 2. 2 is 7. 1, 2, 3, 4, 5, 6. Did I miscount? 2, 3, 4, 5, 6, 7, 8. So 2 should go to. Why is 2 7? I mean, it shouldn't be 3 though, so that's definitely wrong. What is 6? 0, 1, 2, 0, 1, 2, 3, 4, 5, 6. 6 is 6. Maybe I drew this wrong. I need a better drawing thing. Oh, 8 is to 3. No, but no one points to 8. Alright, I have to draw it again. 0 point to 3. 1 point to 6. I can't believe I'm wasting so much time debugging. 2 point to 1. 3 point to 0. 4 point to 5. 5 point to 7. 6 points to 4. And then 8 points to 3. 7. No, 7 points to 4. Am I misunderstanding this part? I don't get it. How am I off by so much? 8 is 3. Okay, alright, that's fine. It's fine. 0, 28. Okay, so there are only 6 nodes, right? Why is there 2 is did I misunderstand this problem? Different nodes, okay, yeah. What am I doing? I drew the same graph twice. No, that's not true. I drew 6 to 4. Okay, 0, 1, 2, 3, 4, 5, 6. 6 points to 4, so I had the wrong pointer before. But no, wait, 0, 1, 2, 3, 4, 5, 6, 7. There's no 8. Why am I? Oh, that's why. Why am I so dumb at counting? Okay, let's do this again. 0 to 3. I'm just getting drawing works. 1 to 6, 2 to 1, 3 to 0, 4 to 5, 5 to 7, 6 to 4. 6 to 4 is right. And then 7 to 3. I see. Okay. I see. So 7 should be 3. That's right. 5 should be 4. That's right. Oh no, I'm getting it wrong. Why is 5 to 7? Let's print things out. Oh, visited may be wrong. No, that should be right. Maybe. Of course, it'll be easier if you look at it afterwards. Maybe I have to reset the T's or something. Okay, so the T's are confusing. I think that's why. Because we do 0, and that handles the 3, and then we do a 1, and then we go oh yeah. No, but we don't use it, do we? Do the 1 looks at the answer for 1 is 7, but it is giving 3. Why is it giving 3? 1 this is such a textbook problem, but I'm like messing it up. What? So if node is 1, then what happens? So 1 goes to 6, goes to 4, goes to 5, goes to 7, right? So 7 is 3, which is right, and then okay, so 0 and 3 is fine, and then 7 is 3, but then 5 is 3. Why is 5 3? Because we don't do this until thing, maybe? I think we don't reset. No, we do reset until. Okay. So then now the 7 until is none. Right? So, oh, it thinks it's in the cycle then. So that's a recursion. And then else if found. If or until is none. I think that means that we don't have to find it. Is that right? 27254. Really silly mistake here. Also took a while to debug. Alright, let's am I actually right? Let's also double check, because I feel like I've made this mistake before where I fixed one thing and broke other things. Okay. I mean, that really should have been done quicker. I'm just really not practiced about it. Yeah, a lot of people got it. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.